Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. Today we will discussing with the constant volume process, or you can say isochoric process. So today we are discussing with the constant volume and making some of the relations between internal energy, temperature, pressure, volume. So let us start with the isochoric process, in which it will be considering as a non-flow processes. So in case of non-flow process is one in which there is no mass interaction across the system boundaries during the occurrence of the process. So it will be dividing into categories: constant volume, or you can say the isochoric process. Sometimes it will be constant pressure, or you can say the isobaric process. Constant temperature, or you can say the isothermal process. Adiabatic process. So your body, it will be act as a 100% insulation, so there is no heat transfer, so it will be called as a adiabatic process. Polytropic process. So today in this lecture we are only interested to learn about the constant volume process or isochoric process, and making the sum of the relations between pressure, volume and the temperatures. So let us start with the isochoric process or constant volume process. The working substance in contained in a rigid vessel. So as from the figure shows, a closed vessel in which gas is filled, so that volume becomes constant. At the one of the end it will be the fixed piston. So fixed pistons and boundary is fixed, so no work can be done on the system or by the system. So by heating of that particular cylinder and transferring the heat from burner to the gas, so pressure is increasing from, you can see onto the PV diagram, P1 to P2. That means pressure is increasing, but the volume V1, that is constant. So V1 equal to V2. So in this PV diagram, or you can say the pressure versus volume diagram, just pressure is increasing with constant volume. So that will be known as a isochoric process, or you can say the constant volume process. So when a gas is heated or cooled inside a closed rigid vessel, then such process of heating or cooling is called constant volume process. We are already discussed here, burner it will be heating the gas into closed vessel at constant volume, so only pressure is being increasing. So let us see onto the PV diagram, P in terms of bar, V or volume in terms of meter cube. So state 1 P1, it will be having a minimum pressure at constant volume, or you can say V1, increasing the pressure P2 at V2. So as from the PV diagram, V1 equal to V2. So constant volume process. So heating process representing over here 1 to 2, and cooling it will be 2 to 1. So in case of heating of that particular gas which will be present inside the vessel, that will be increasing the pressure. But in case of cooling from 2 to 1, that will be reducing the pressure from P2 to P1, and that will be representing onto the PV diagram. So the process will result in an increase or decreasing into pressure. All the heat supplied during this process will be stored in the gas as an internal energy. So as from the first law of the thermodynamics, heat supplied, that will be equal to work done by the system plus stored of internal energy into the system. So that will be dQ minus dW, that will be equal to internal energy. So starting with the relation between pressure, volume and the temperature. So P1 V1 upon T1, that will be equal to P2 V2 upon T2, but the volume remains constant, so V1 equal to V2, so it will be modified P1 upon P2, that will be equal to T1 upon T2. So that will be representing as a GAY-LUSSAC law. So in that GAY-LUSSAC law, it said that at constant volume process, so V1 equal to V2. So final relation of the GAY-LUSSAC law, P1 upon P2 equal to T1 upon T2. Work done in this kind of constant volume process, P into dV from state number 1 to state number 2. So P into V2 minus V1, but for constant volume process V1 equal to V2, so work done that will be equal to 0. Now third category, change in internal energy. So as from the first law of the thermodynamics, change in internal energy, that will be representing as a U2 minus U1 equal to heat supplied minus work done, but here work done it will be considering as a 0. So only mCV means constant volume specific heat into temperature difference, so that will be representing as a Q, heat supplied. So du, change in internal energy, that will be equal to mCV T2 minus T1 kilojoule. Next category, heat transferred. So as from the law of the thermodynamics, dq equal to dw plus du, we already discussed, but work done is becoming 0. So dq equal to du equal to m into specific heat at constant volume into T2 minus T1 kilojoule. Note, if T2 is greater than T1, then heat supplied and will be positive. If T2 is less than T1, then heat is rejected and it will be negative, and it will be the very important part. Heat supplied increasing internal energy and rejection decreases internal energy. Change in enthalpy, H representing internal energy plus work done, P into V. So for the state number 1, H1 equal to U1 plus P1 V1. Similarly, from point number 2, H2 equal to U2 plus P2 V2. Thus, change in enthalpy delta H, H2 minus H1. So just put the value of H1 and H2. So U2 plus P2 V2 minus U1 plus P1 V1. So U2 minus U1, that will be plus P2 V2 minus P1 V1. So U means mCV into T2 minus T1 from the previous equations where work done becoming 0, and put the value of PV equal to MRT. So P2 V2 equal to MRT1 minus T2. But Cp minus Cv equal to R, so Cv plus R equal to Cp. So delta H equal to mCp T2 minus T1. So that will be the final relation. If you like it, then subscribe. like, share mechanical magic, mechanical learning tutorials. Thank you very much.